Hello and welcome to my channel. In this video, I'll be covering Caesar by CS50's Introduction to Computer Science. So what we are supposed to do in this problem set is enter a command line argument when we are running the program, which is gonna be the key, and then with accordance to the key, we will be encrypting the plain text. So let me just quickly download the files that are required for this problem set. Alright, so this is the code given to us by CS50 and we'll just be adding on to that. So there is some background here. I'm sure you guys have read this already, and Brian has also gone through all of this, and this is the equation and the formula that we will be using to solve this problem set. Many of you might not be understanding this formula. I'll be going through it later on, and here we have the specifications and a step-by-step outline on what we can do to solve this problem set. Here we have the step-by-step outline in much more detail, and I'll be using that to solve this problem set. Advice how to begin. Let's approach this problem one step at a time, which is here. So first and foremost, we want to read the command line argument, and the first step they're telling us to do is to check if the user is complying with the input requirements, which is to enter /Caesar, and then afterwards we add one number as the key. So if he's not complying, we will just be printing user /Caesar. Okay, so that's pretty straightforward. How we can do this part is first check if the arguments entered are only two. This is one and this is one, so total 2. So argc, if it's not equals to 2, we want to print usage./Caesar. Alright, so printf usage./Caesar, and we want to return a 1 as they have told us here. However, if the user has complied with the requirement, we can just return a 0. And I'm sure this will work, so I won't be running this. Second step is to check the key. So this time around, we'll be checking if the key entered by the user is only digits. In the scenario where the key entered by the user is anything other than digits, we'll be printing usage./Caesar key. So they want us to create a self-declared function only digits, which will be returning a boolean and taking in a string. Only digits, string, text. So far going smoothly. This was the function prototype, and this is going to be our function. So alongside this, we want to add in the AND operator and check if it's only digits. If in the scenario where it's false, then we want it to print /Caesar key and return 1, just like what we did for counting command line arguments. So only digits will be taking in argv1, the key. Okay, so now let's check if the input is only digits. How we can do this is by perhaps making use of the many functions that C programming provides for us, which we can use the manual.cs50 to C. So as we can see here, there is a function that is checking is digits. So let's take a look at how to use this. Is digits, it takes in a char as input and checks if the character is between 0 to 9. So since it takes in a character as an input, we will have to use a for loop and index into every character in a string. So let's just define length here, and length is gonna be equals to string length text. I'm sure many of you guys are familiar with string length. Let's just take a look at which header library provides that, which is string.h. And I just recalled we have not added in ctype.h for this is digit function. Okay, so let's add that in as well, ctype.h. Okay, now we have that. So now we have this length. We want to index into every character, int I equals to 0, I less than length, I increments. Okay, nice. So now we want to check if the characters are digits. So if is digit text I. So as we can see here, the function returns a non-zero int if C is a decimal digit and 0 if it's not a decimal digit. So if this is not 0, so if in the case where the output is 0, we will just want to not the 0 to make it true, and if it's true, we want to return a false. Return false. And if it has passed through the loop successfully, we know that every character in this text is a digit, so we can return a true. Okay, so that's all. Let's just check if this is working correctly. Make Caesar. Okay, wow, no errors. Let's try out some of the cases. So /Caesar, banana. Okay, so this doesn't seem to be working correctly. Okay, so I've seen the error already. We are using the AND operator. We're supposed to use the OR operator. What's the difference? As for the AND operator, we need both these two conditions to successfully pass for it to enter this loop. However, for the OR operator, any one of these conditions can succeed and it will still enter the loop. So that was the problem. Let's make Caesar one more time and let's run /Caesar banana, and here we go. Usage /Caesar. I'll just add in a \n as well. So here we go. We got the first two steps already. So now we want to convert the string key into an int key. And then afterwards, we want to use getString to prompt the user for a plain text. Okay, so let's do that first. We want to convert the key into a string, which we can use a to I function, which we can find here. A to I converts a string to an int. That's all. That's what we want. Let's add in the header, which is required for us to use this function. So key, let's just add in an int k. So k is gonna equals to atoi argv1. So here we go. Now we have the key in int format. We want to print plain. We want to prompt the user to enter plain text. So plain text equals to getString plain text. Okay, so that's about that. So now we have finally came to the rotate function, which most of you guys have came here for. So what's the rotate function doing? The rotate function is taking in a character as input as well as the key, and we'll be wrapping around and rotating the character with accordance to what the key is. So let's say the character is A and the key is 1. So now it will rotate to B because the key is 1. Okay, if for example it's D, the character which is passed into the rotate function, it will be rotated to an E. Okay, key 1. Okay, so now how is this done? This is done by using the formula that they have provided to us in the problem set, which is CI equals to PI plus K modulo 26. So this is basically the formula that which we'll be using in our rotate function. So first and foremost, what is PI? PI will be depicted as the sequence, as the position it is in the alphabet. Okay, so let's just take a look at the ASCII chart, which the problem set has provided for us. As you can see, A is the first letter in all of the alphabet. So A is going to be depicted as 0, okay? And B is going to be depicted as a 1. C is going to be depicted as a 2, okay? So this is the input which is given by the user. So we'll be taking this 0, for example A, okay? For example, if the input is a this is going to be 0 and K is going to be 1. Now, why do we have this modulo 6? I'll be discussing this later on. So first we can take, this is going to be 1, okay, modulo 26. So 1 divided by 26 is going to be 1. So as you can see here, the input 0 and then the output 1. So it's going to be A converted to a B because the key is 1. So the input is the position of the letter in all of the alphabets. So if the input is A, this is going to be 0, B is going to be 1, C is going to be 2, etc. K is going to be the key, and it will just output the position of the ciphered alphabet. So as you can see here in the above, A is converted to a B, okay? And then let's say, for example, this key is 3, okay? So let's say the key is 3 and the user and the input entered is still an A. An A is a 0 in the position of all the alphabets. So 0 plus 3 modulo 26. So 3 divided by 26, what's the remainder? It still equals to 3. So as you can see here, the A is converted into 3. And what is 3? 3 is going to be equals to D. So as you can see here, an A is converted to a D because we have the key of number 3. So it's going to be shifted by 3 to all the way to D. B, C, D, 3 letter difference. So this is basically how it works. So let me just run through all of this one more time. This PI is the position of the letter in all of the alphabets in numeric form. Position number 0 is A, position number 1 is B, position number 2 is C. K is the key entered by the user. If you want to rotate the letters by 1, this K is 1. If you want to rotate all the letters by 2, this K is going to be 2, etc. This 26 is here. Now I'll be going through why this 26 is here. Okay, let's say in the scenario where PI is equals to Z, okay, and K is equals to 1. Okay, so in this situation, what's gonna happen? If we make use of this formula once again, PI is gonna be what? Z is the 26th letter of the alphabet, but we want to minus 1 to it, okay, because the alphabet starts from 0, 1, 2, 3, 4, 5, so Z is 25. So here we substitute 25. K is going to be 1. So now what's the situation? The situation is that this is going to evaluate to 26. And then 26 modulo 26, 26 divided by 26, the output is 0. 0 is A. So when you add 1 to Z, it will move all the way to A. Let's say if the key is 2, it's just gonna plus 2, and the remainder is gonna be 1, which is B, and so on and so forth. So this is ultimately how this formula provided to us works. I hope you guys understand. If you guys don't, just spend more time contemplating and thinking about how this equation works by providing your own examples and just doing guess and check. Or you guys can just comment down below for further questions, and I'll try my best to reply to every single comment. So now moving on, I will be finally implementing the rotate function. So let me just quickly create the function prototype. Returns a char, character P, int K. P representing the plain character and K representing the cipher key. Now let's populate the rotate function. Okay, so now we want to implement the formula that CS50 has provided for us. Let's just copy it down. Alright, so PI is gonna be the position number of the letter in the alphabet. And for that, as you can see in the ASCII code, for A to become 0, we have to minus 65 to the capital A. As for the lowercase a, we have to minus 97. So in this rotate function, we have to make a distinction and figure out if the character passed into this function is a capital letter or a small letter. Alright, so for that, we can use the function provided to us, which is gonna be the isUpper or isLower function. I'll start off with isUpper. So if isUpper P, then we'll enter this statement, else if isLower P, then we'll enter this statement, else we'll go with another situation. Okay, now let me just include this into every one of them. So we want to convert P to PI. How can we do this? As for the capital letters, we have to minus 65. Okay, so PI equals to P minus 65. So for example, A is 65, we minus 65, then we're gonna end up with 0, which will be put into here. 0 plus, for example, the key is a 1, it's gonna return the correct output, which is gonna be a 1 here. So A is gonna be converted into a B. However, this output is gonna be a 1. We want this output to be a 66, okay? Because a 66 is equivalent to B here. So how can we do this? What we can do is C equals to CI plus 65. Okay, so we have 1. We want to convert it to 66. We can just plus 65 to it. Pretty straightforward. But before we get any annoying errors, we can just declare the PI and the C. So character PI, C, done. This is for the upper function. Now let's populate the lower function. As for the lower function, this is going to be 97, and this is going to be something similar. We want to convert the 0, we want to convert the 1 to a 98. Okay, so to convert it to a 98, we have to add 97 to it. You can see a pattern. In the very beginning, we minus by 65 to get the position of the character, and then at the end, we add 65 to get the actual ASCII value of the character. Okay, I hope it's clear. If it's not, comment down below and I'll try my best to help you guys out. Now, if in the situation where it's not a uppercase character or a lowercase character, it's just a normal character which is not a letter. So in that situation, we could just simply return P, okay? Because we don't want to make any changes to it. We're not rotating it whatsoever. In the other cases, we are gonna return the C, okay? So that's it for this rotate function, if I'm not wrong. Now we have the rotate function. How are we gonna use it here? So we have the plain text. We have to create a ciphertext string. So we have to create a ciphertext character array to hold all of these characters here. Okay, so let's create a character array. Gonna be ciphertext, and what's gonna be the size of the ciphertext? It's gonna be equivalent to the plain text, and for that we have to use the string length function plain text. Okay, so now we just insert the length here, but that's not it. We have to +1 to include the now terminator. Okay, a now terminator is gonna tell the compiler that we have reached the end of the string. So now we have the ciphertext string to hold all our values. So let's loop through int I equals to 0, I less than length I plus plus. So now what we're gonna do is loop through the entirety of the plain text, and we are gonna rotate all the characters in the plain text by indexing into all the characters, and then putting in the rotated text, the ciphertext, into the cipher string or character array. You can use these two words interchangeably. So now ciphertext is gonna equals to rotate plain text I. Okay, so we're gonna index into the first character, rotate it, put it into the ciphertext, and then we're gonna go to the second character of the plain text, rotate it, and put it into ciphertext. Okay, so that's it. And then at the very end, we want to end off the character array with a now terminator so that we can tell the compiler, the C compiler, that the string has ended, so that we can print it out onto the terminal. Okay, so that's pretty straightforward. We have to do this. Alright, so it seems to be correct here. Let me just check for semicolons. There we go. Yep, semicolons, return P, return C. Okay, looks alright. Once again, we are looping and indexing into every single one of this plain text and rotating the character and putting it into the ciphertext. Should be pretty clear. And yeah, let's just cd Caesar, make Caesar. Pretty sure there'll be errors, but oh well. Yep. Okay, so it's gonna be string plain text. Okay. Alright, any more errors? No, does not seem so. Make Caesar. Okay. Ciphertext. This is the declaration. Forgot to put semicolons. Make Caesar. Some errors. Char rotate. Too few arguments. Oh, okay. Sorry about that. Along with this, we have to enter the key as well. That was my mistake. Oh my gosh. Use of undeclared identifier CI. My bad. CI here. Okay, done. Finally. Okay. Now hopefully it works. /Caesar. Let's just enter 1. Now they're asking for plain text ABC. It's gonna be BCD. Yep, correct. I just seem to be missing a \n. Ciphertext, plain text. Alright, seems to be okay. Let me just make Caesar one more time. Let's try this, huh? /Caesar 13. Okay, the plain text is gonna be sure to drink your Ovaltine. Okay, so it seems to be alright. The uppercase letters are still uppercase. Awesome. Time to just give it a quick check 50 and hopefully all is right. Alright, so everything seems to be correct. We've come to the end of this video. I hope you guys enjoyed this video. If you guys did, hit the like button and subscribe, and comment down any questions you guys have, and I'll be happy to answer and help you guys out. That's been this video, and see you guys in the next one. Bye bye.